number proofs, right? We have our direct proof. We have a proof. Now this is where the language comes in. Proof by contraposition. So remember what that is? That's the two-step one. That's the swap and negate, both. And we have a proof by contradiction. These are the three ones that we'll hopefully look at today. Yep. So the direct proof is probably the most straightforward because you've done stuff like this before. It's like your standard deductive kind of proofs where you have some kind of statement and we just got to like prove it using some creative algebraic subjects. So what I mean by that is, for example,
so direct proof's like a normal proof?
Yeah, sort of like a normal proof, right? We still have to sort of introduce some variables, right? So we can let P be our number, doesn't really matter, it's kind of arbitrary. Now if something's odd, how do we denote something being odd? Good. So what was that? Yeah, okay, be more specific. So n plus 1, n could be anything. N could be an odd number. And then you have an even number. So yeah, we usually say 2k or 2n plus 1. That guarantees that would be odd. Because you do 2 times something, that's always even. You add 1 to it, that becomes odd. And we'll put some bounds here. Let's say k is an integer. So we're using the notation here, right? So what I need to prove is that the square is also odd. So what would be p squared in this case? Well, that would just be that whole thing all squared, right? 2k plus 1 all squared. Where can we go from here? What can I do here, Matt?
So if the number is odd, then it's the square.
So how do I show that this is odd? Well, I don't have much options. What can I do with this, really? I could, but then I go back to p. Sorry, I'm not really going anywhere. Yeah. Good. We could expand. Why do you seem hesitant to do that? Let's try it. It's the only thing you can do, right?
If we expand it out,
Yeah.
and then we use induction to prove it's always odd.
Here's what you're looking for. How do you know if something's odd or something's...
Because it's 2 variables plus 1. Right?
2 variables plus 1?
So you gotta make sure there's a number there.
Yep. Okay, so here's the thing. I believe you that you put anything in here and you get like here and you add 1, you get an odd number, right? Is that what you're saying? Yeah. So here's the thing with proofs. You have to make sure everything is very clear. It has to be on like reasonable doubt, right? So I'm not convinced at this point that this is even. How can you really show me that it is? How did we talk about an even number? It was 2 times something, right?
So saying we get that bit.
Yeah. Yeah. This is equal to 2k? As you're just kind of saying, oh, let this equal to 2k. That's kind of cheating, right? You have to rearrange this expression.
Oh, wait, to make it so that inside is 2k. So
Yeah. I'm going to make it even easier. Just take out 2. If you just take out 2, right? Because why is this even? It's because it's 2 times something. Sorry?
So don't take it.
But k could be, yeah. You could take out 2k as well, actually. But I'm just going to take out 2. Because I'm going to get 2k squared plus 2k, right? The reason why I do this is because 2 times anything is an even number, yeah? Right, so it makes it very clear that this is always even, yeah? So 2k squared, just make a statement about that. Not convinced? Well,
I'm convinced.
like this one here, why can you do this one, right? Are you convinced? Are you sure? I can go back still.
I'm convinced.
Okay.
No, don't worry.
So 2 outside of 2k squared plus 2k is always even. Therefore, hence 2 outside of 2k squared plus 2k plus 1 is always odd. And p squared is odd. Okay? So that's like a direct proof. All we're doing is we introduce some p and then we like do as they asked us to. We squared it, right? And then we had to do a bit of rearranging to convince them that, hey, this is actually always going to be odd. This step here, this is really not enough. Like I know the next step, and whoever's marking will probably know the next step. But the thing about proofs, and you learn with induction, right, is like don't skip too many steps because otherwise it's not going to work out nicely for you. Do you want to try another one? This one's actually easier. Do you want an easier one or do you want a hard one?
Always hard.
Hard? Okay. P squared is odd?
No, yeah. Like hence 2. Both ways, always.
Even. Sorry. Odd. Always odd. Yeah.
Therefore,
P squared is odd.